So what can we take away from this code? Well, the first thing is that this first use of BGE, branch if greater than or equal, might seem a little strange because that is certainly not what we put in the code. We don't want to check if it's greater than or equal. We want to check only if it's greater. But because the code has already gotten past a branch if not equal, by the time it gets down here, it knows they can't be equal, and therefore it's safe to use the branch if greater. Furthermore, you see another branch if greater later on, which is weird because you're checking for less than, but it can get away with that because it just swaps the orders of the operands. So here it was A5 greater than or equal to A4, and now you switch the order and it's is A4 greater than or equal to A5, which would actually be a less than. Because again, the code knows that they're not equal at this point. Now I just want to show you the ghost of Christmas future, and that is the fact that most reverse engineers do not look at code in straight line assembly. They can see things in a much nicer form that is called a control flow graph. So once you start dealing with lots of control flow and lots of nested ifs and elses and switches and whiles and fors, it is very helpful to have control flow graphs. And that's exactly what tools like Ghidra will give you. Now that doesn't help you for now. We're just expecting you to go through the code in GDB looking at straight line assembly, but this is just to say things will get easier later on. Specifically, if you're going down the reverse engineering path. If you're like a developer, then, well, you just got to use whatever tools are available. Okay, picked up new assembly instructions. We are now into these branch instructions. BNE, branch if not equal. BGE, branch if greater than or equal. Putting those on our diagram, we're going to pop up BNE and BGE over here and start ourselves a nice little control flow area.